Assalamualaikum and hi everyone. Today we are going to discuss on parametric equation of lines. The learning outcomes of today's lesson is to determine the parametric equation of lines. Let's say we have a line L, right? We have a line L passing through point at naught, where n naught is x naught, y naught, z naught. Okay, so the line pass point at naught, x naught, y naught, z naught, and the line L is parallel to vector non-zero vector v. Okay, this line is parallel to v, right? So n, x, y, z is an arbitrary point on L. So n is a point on L, an arbitrary point, all right? And we have vector r naught represent O n naught, vector r represent O n, and vector w represent n naught n, right? All right. So if you look at here, okay, so r, okay, vector r, it is equal to r naught plus w. Okay, since w and v are parallel, so we can write w is equal to tv. All right, and at last we have r is equal to r naught plus tv. All right, and if we replace r naught is x naught, y naught, z naught is a vector o n naught. It is a vector x naught, y naught, z naught, and t multiply with vector ABC, V is ABC, so towards the end we get R is a vector x naught plus AT, y naught plus BT, z naught plus ET. It is also named as vector equation of line L. So x naught plus AT, y naught plus BT, z naught plus ET is called as vector equation of line L. And if we take the element for vector equation, so we have parametric equation of line L. So this represent x is equal to x naught plus AT. Okay, this one represent the y naught plus bt, and then the last element of vector represent that will be z naught plus ct. And we can also write symmetric equation of line L. Okay, it is written as x minus x naught divided by a is equal to y minus y naught divided by b is equal to z minus z naught divided by c. So for our parametric equation, we can have three ways to write the equation. First, we can write it in terms of vector equation. We can also write it in terms of parametric equation, and we also can write it in terms of symmetric equation of line. Okay, now we look at the procedure, okay, to find the equation of lines, all right. So the first one, we are going to determine which is the vector parallel to line L. Okay, so let's say here the vector is ABC. Okay, we also need a point on line L, all right. Let's say it is x naught, y naught, z naught. So therefore, we can calculate or we can write the equation of the line L. Okay, it is parametric equation is given as x naught plus at, y is equal to y naught plus bt, z is equal to z naught plus ct. And this is the vector equation of line L. And lastly, this is the symmetric equation of the line L. So it depends on what is needed, okay, whether we are going to give in symmetric equation or parametric equation or vector equation. Okay, before that, all right, it is also very important to draw the figure, okay, showing the vector parallel to L and point on line L to make our understanding on the situation more easier. Okay, we look at the first example. Okay, we want to find the parametric equation of a line passing through point 1, -2, -3, and the line is parallel to 4i plus 3j plus 2k. So if you look at here, we have a line parallel to vector. It is a line is parallel to vector v. Okay, 4, 3, 2. Okay, so here it means that vector v, if we compare to vector parallel to it, so we have a is equal to 4, b 3, and c 2. Alright, we also have a line point on the line, which is point 1, -2, -3. So therefore, the x naught is equal to 1, y naught is equal to -2, z naught is equal to -3. Alright, so this is the situation of the example. Okay, we have a line here, L. This is the line that we are going to determine the equation. We have a point on it, and this is a vector, 4, 3, 2, parallel to the line. So therefore, we can write the parametric equation of the line, okay, using the parametric equation formula. So we have x plus x naught plus 80. So therefore, we get x is equal to 1 plus 40. Y is equal to -2 plus 3t. Okay, based on y naught and b. Z is equal to -3 plus ct or -3 plus 2t. So this is the equation, parametric equation of the line. Okay, and this is the vector equation of the line. Okay, we just take the x, y, and z, okay, and put it in the vector form. So that is the vector equation of line L. And this is the symmetric equation of line L. So we replace x naught with 1, a with 4. So x minus 1 divided by a by 4, y minus 2 divided by 3, we get this one. Z minus 1 3 divided by 2, so we get this one. So this is the parametric equation, vector equation, and symmetric equation of the line given situation, points, and vector parallel to it. Okay, now we are going to look at the example 2. Okay, we want to find the parametric equation and vector equation of line passing through point 2, negative 1, 3, and parallel to vector v, and we also need to find the other 2 points on the line. Alright, so we have vector parallel to the line is 2i plus 3j minus k. Okay, so that is the we get the a, b, and c here. Alright, so we have point on the line. Alright, so 2, negative 1, 3. So we will get the x naught, y naught, z naught here. Alright, so this is the situation here. Alright, we have a line F, point on the line 2, negative 1, 3, and the vector 2, 3, negative 1 parallel to line F. Alright, this is the equation of the parametric equation of the line. Alright, now what we are going to do is we want what are other points on the line. Alright, what are other points on the line? So this is to answer the second part of the example. Alright, so we have that is the equation of the line. Okay, so if you look at here, so when t is equal to 1, so we replace here, substitute in the x, we get 4. We substitute t is equal to 1 in y, we get 2, and we substitute in z, we get 2 also. And when t is equal to 2, we substitute again, we get x is equal to 6, y is equal to 5, and z is equal to 1. So therefore, the other 2 points on the line L, on this line, would be 4, 2, 2, and 6, 5, 1. So it is actually can replace any value of t here, okay, to get other points on the line. Okay, now we want to find the parametric equation and symmetric equation of a line passing through 2 points. Alright, so if you look at here in this question, we only give you 2 points, okay, but we don't have the vector parallel to the lines, okay. So if you look at here, we need to find the vector AB. It is a vector parallel to the line. So vector AB, if you look at here, it is negative 3, 4, negative 8. Alright. So a point on the line, alright, we choose 2, 4, negative 1, alright. So we have x2, y4, z not is equal to negative 1. Alright, actually we can also pick up 507 as long as the point it is on the line. So this is the point actually. Alright, if we draw this one, okay, this is vector AB, alright. So we can find, of course, the line L is parallel to vector AB. So that is why in step 1, we pick up the vector parallel to AB as AB also. Alright. So this is the point here. Alright. So we choose point B. You can choose point A also. Okay, in step 2. Alright, then we can write the parametric equation of the line as step 1. So this is the parametric equation. X is equal to 2 minus 3t. Y is equal to 4 plus 4t. And z is equal to negative 1 minus 8t. Okay, and this is a symmetric equation. We have this is a symmetric equation by using x minus x naught divided by a is equal to y minus y naught divided by b, z minus z naught divided by c. Alright, now we give you this example 4. Okay, given 2 lines here, okay, line L1 and line L2. We look at here line N1 and line L2. Alright, find the parametric equation of the line. Okay, this is not line N1 and line L2. Okay, this is line L1. Okay, this is line N1. The blue one is line L1, and line L is the line that we are going to find the equation. Okay, so we want to find the parametric equation of the line 3 to negative 1 and parallel to L1. Okay, this is L1. Okay, so if you look at here, line L, so line parallel to line 1. L, okay, line L, this is line L, okay, is parallel to line L1, alright, which is line L1 is parallel to 3 to negative 4. Okay, from the equation of the parametric equation of line L1, we can get vector parallel to it. So that is 3 to negative 4. Alright, so we have point on line L, okay, because we want to determine the equation of line L. Alright, so we take the equation at the point as 3 to negative 1. Alright, so you have to be careful which point to take. Alright, so in this case, because we want to determine the equation of line L, so therefore the point must be on line L. Alright, so we have x naught, y naught, z naught here. And we can write the parametric equation of line L. Alright, this line, the purple line, this is the line that we are going to find the parametric equation. So we get it as 3 plus 3t, 2 plus 2y is equal to 2 plus 2t, z is equal to negative 1 minus 4t. Okay, here's some question related to parametric equation and symmetric equation of line. Okay, you can try these questions at home. We will discuss it in the next lesson. Okay, that's all for today. Stay safe, stay healthy.